Hello, my name is Lindy Hong,
And my name is Ankit Agarwal, and we are freshmen at UC Berkeley.
and this is the game we created for our class CS61B at UC Berkeley. And this game was for Project 2 in the class. So, for class policy reasons, we won't be allowed to show you our code, but that may change in the future. But right now, we'll only show you how what our game looks like, and explain to you how our game works and the mechanics of it.
Yeah.
So we'll start by entering the game by pressing N and entering a random seed.
All right.
So this is level 1 of our game, and basically our game is just a 2D tile game, and the objective of the game is to collect all the keys, so the yellow characters as you can see right here, and once you collect all the keys, you unlock the door, and you can walk through the door and progress to the next level. And you win by advancing through all the levels, and right now there's currently 4 levels.
Great. So right now you don't really see much going on, but we just encountered something that's a little different. This is an NPC called a villain, right? And basically, they try to like sort of like if you guys make contact on the same square, then you're gonna lose health, which is displayed down here. And that's another feature of our game or mechanic. Another sort of creative mechanic that we added are switches. See if I can find one of those switches. Here. This switch basically lights up the entire map for a little bit, and it allows you to see the map. Yeah. And the final, what's it called? The final mechanic that we sort of made was the levels themselves, because we made it so that the levels aren't hard coded. That you can basically, if you wanted to, you can enter the number of levels you wanted, and the game would scale accordingly, making each level a little bit harder every single time. But I'll explain more about how that works. So before we get to that, we want to describe exactly how we generated the map for this algorithm, because this is all done from scratch.
So to generate the map, we first created randomly sized rooms, and at first all the rooms are just randomly generated within a circle, so they're
like a small circle.
So they're distributed, along the circle, and they're all like piled up on top of each other. So we used a separation algorithm to separate all of them, and then we choose random rooms within like all the separated rooms.
And the separated rooms, we choose random rooms such that they're inside the dimensions of this like world.
Yes.
Yeah.
So after choosing the rooms, we created hallways to connect all of the rooms, and the way we chose which rooms would be connected by hallways is that we ensured that each room was only separated by 2 walls. So to travel to a room, you only had to pass through 2 walls, and then we used a graph algorithm to make sure that the entire world was connected and that no room could be like unreachable.
Yeah. Okay. So, yeah. Now let's talk more about the actual game itself and the levels. So, the first thing I want to explain more about is the switches. So basically, how this works is that we have a generated display world, and then a generated like player world with all the players, and then when the switches turns on, this entire board lights up. But if the switch is not on, if no switches are on, like let's say I walk for a little bit and this thing turns off, then only a radius of squares are visible to the player. Now, once we step on a switch, the number of moves that activates is around 20. So after 20 moves, it'll turn off. Okay, the next creative mechanic we want to explain is the villains themselves. So the villains, there's basically two ways, two moves they can make. Two types of moves. They can make a move that follows the player, or they can make a random move. So the way we implemented this is we have radius of vision for each NPC, and we also have a attack coefficient. So the vision radius, like basically if the player, the player is within the vision radius of an NPC, he will his ability to follow you will turn on, and the idea is that if the attack coefficient is high enough, then the villain will start to follow you more often. But if it's low, then he won't really notice you that much. and this coefficient increases as the levels increase. Yeah. So the idea is if a villain sort of like you make contact with a villain, let's say I try to do some see if I can make him touch me. Come on, there. Then we call it a collision, and you lose a little bit of health down here, as you can see. So, yeah. All right. The final thing I want to explain is the actual levels. So let's just go to a different level. Hopefully I can win this, and then we can move on. Last time we tried this, it didn't really work out that well. So, all right. I believe I've unlocked the door, which is up here, so I can go to it. If we hover on the tile, we can see unlock door, which is nice. So, oh, whoops. Good thing we have the switches. All right. So we enter, and we get to level 2. Now, level 2, it's another room that's completely randomly generated. It's not the same room. It's completely different, and that's a feature of our algorithm. So, as you can see, there are a lot more keys and a lot more villains in general. Also, yeah, and basically, what's gonna happen now is these villains are gonna be more likely to follow you. So if I just if I move around a little bit, like these villains, they start to follow me a little bit more. If I'm in the general like vicinity, like you can see that these villains are just they're starting to crowd around me a little bit more. And this is the reason that makes this game a little bit harder is because now they're more likely to follow you. Also, the number of villains also increase. The way we did this is we used a random number generator, a linear Gaussian model. Basically, it increases linearly, but there's some noise added to it. And then we did this for the attack coefficient and the number of villains. So the number of villains will increase a little bit with some noise, and the attack coefficient of the villains will increase with some noise. Other things that increase that also have noise added to them are the radius, the vision radius of the villains themselves, the number of keys, and the number of switches. So, like for instance, in this case, there's a lot less keys than there were before, but that's just because the algorithm chose like this many keys for whatever reason. Yeah. Things we kept constant are like the health, the radius of the vision radius of the character, and stuff like that. But theoretically, we could make those also change into random numbers if we wanted to. Okay, yeah, I think that's basically does our game. I just want to show you what happens if we lose, because I'm probably not going to just play around here until I am at 2 hearts, and now I am at 1. I've lost. So you lose, the screen pops up, and then it goes back to the home screen after a while, and you can simply just quit. All right. Thank you for listening to this sort of
Explanation
of our game. If you want to contact me, you can contact me at my email address, aagarwal @_601 @berkeley.edu, or you can contact my partner, Lindy Hong, at
berkeley.edu.
Well, what's your info?
Oh, Lindy Hong at berkeley.edu.
Yeah, exactly. All right. Thank you for listening, and I guess we'll see you later.